one of the most important and spectacular discoveries in astronomy was made using this 193 centimeter diameter telescope behind me. This is part of the Haute Provence Observatory, where 30 years ago, the first exoplanet orbiting a solar-type star was discovered. To find out more about this telescope and the observatory, I am now joined by Guillaume Ebrard, who is an astronomer and a CNRS senior scientist. Thank you very much for your time. Can you provide an overview of this observatory?
So that observatory, Observatoire de Haute Provence, was created long ago, just before World War II. Actually, it was created by at that time in France, at the government, there were several scientists who played an important political role in our country, and in particular Jean Perrin. Jean Perrin is a famous physicist. He's as famous as he obtained the Nobel Prize in physics, but also he was a member of the government and created a lot of important things in science. For example, CNRS, which is one of the main research institutions in France, and also Observatoire de Haute Provence, so the observatory where we are here. And the telescope we see here, which is the largest of the site of the observatory, it was built during the 50s.
How did this observatory become the center of exoplanets discovery?
So I'm not sure we can say it is the center, but it was the pioneer. It was the location where the first discovery was made. Actually, at that observatory, it was a long story of measuring the motion, the dynamics of the stars. And by doing that, you can study if stars have companions. For example, another star orbiting around a main star. So there were several teams doing that, in particular a Swiss team doing that in collaboration with people here at Observatoire de Haute Provence. And so by studying binary star, triple star, multiple star, they look companion of star with lower and lower masses. And what is a planet? A planet is not a star. A planet is less massive than a star. And so by improving the technique, by improving the instrument, by improving the observation, finally they were able to detect not a star orbiting another star, but a planet orbiting another star. They did that detection in an indirect way. It was not a direct detection. They did that detection by studying precisely the motion of a star, and they deduced from that motion that the star was orbited by a planet.
Can you tell us about your discoveries of exoplanets using this telescope?
So I'm part with my colleagues in France and in other countries. We do a research program to try to discover new planets, to try to characterize more precisely planets that we already know. So, for example, one kind of program we do a kind of survey. We select a sample of stars for which we know precisely the mass, the radius, the properties, and we say for this kind of star, which kind of planets we can find. So we look a sample of this kind of stars. We discover planets. For some stars, we don't discover planets, but so for such kind of measurement, we can deduce, for example, a kind of occurrence of planets. How common are planets around stars in our galaxy?
Do you use the same instrument that we see in the background?
Actually, this is the second generation of instruments to study and discover exoplanets. The first one, which was used 30 years ago by the team who discovered the first one, by the two Swiss researchers who did that discovery, Michel and Didier Queloz. So Michel and Didier Queloz, they use, with other colleagues in France and in Switzerland, an instrument which was called LOD. So LOD is a spectrograph. So a spectrograph is an instrument to study precisely the light from a star. Actually, it decomposes in different wavelengths, in different colors, the light from a star. And from that fine study of the color, we can deduce the motion of the star. So that instrument LOD worked for maybe 10 years, something like that. And we changed instrument in 2006. We have a new instrument here, which is called SOFI. SOFI is like LOD, but better, faster, more accurate. Everything is better. And so now LOD, we don't use it anymore. We can see it because this is an historical instrument. It allows the first exoplanet detection. So we can see in a kind of museum downstairs.
Is the SOFI spectrograph part of this telescope's setup?
It's not here actually. What we see here, so the telescope will observe stars. And there are optical fibers at the bottom. We see them here. There are some gray tubes here. Inside, there are the optical fibers. So the optical fibers take the light from the stars that we are observing and put the light through the spectrograph Sophie. And so the spectrograph is downstairs here in a thermal tank.
What's the importance of a spectrograph and what's the difference between the two spectrographs, LOD and Sophie?
The strength of the spectroscopy, when we use spectrograph as LOD and Sophie, is that you can do accurate, fine analysis of the light, and by doing that, you can measure, for example, the temperature of the star which emit the light. You can characterize the chemical composition of the atmosphere of the star, and you can measure precisely the motion of the star, its dynamics. So that's what we do with spectroscopy here. And you asked me the difference between LOD and Sophie. Sophie is most sensitive, so it's easier to detect fainter stars, so stars that were far away by comparison to the ones that we observe with LOD. And Sophie is more accurate. So if it's more accurate, you can detect planets with lowest mass, and you can also detect planets with longer orbital period. The first planets that were discovered here 30 years ago, which is called 51 Pegasi, that planet looks like Jupiter in our solar system, so giant gaseous planets. But that planet orbits in a few days only around its star, whereas in our solar system, Jupiter, it's 12 years to make a full orbit of the Sun. So just a few days for the first exoplanet. It's very strange. It was a surprise to discover such kind of planets. So we call that kind of planet hot Jupiter because it's like Jupiter, but very near the star, so it's very hot. It receives a lot of energy, light, heating from the star. So this planet, a large planet near the star, they are the less difficult to detect. So it was possible with LOD. And after, we tried to detect planets with lower masses and planets with longer orbital period. And for that, you need higher accuracy of the instrument. And so Sophie can do that.
When did you first discover an exoplanet? And since then, how many exoplanets have you discovered?
So first now we know in 30 years more than 5,000 planets were discovered, not all here, but in a lot of observatories on the ground and also with the space observatory. Here at Observatoire de Haute Provence with that telescope, I think we discover and contribute to the discovery, to the characterization of a few hundred exoplanets over the 5,000 we know now. I think more or less I contributed to most of the several hundred exoplanets discovered and characterized here, together with my colleagues. And on my side, I think the first one I discovered directly, I was at the telescope and made the discovery. I think it was in 2006, just a few weeks after the new spectrograph Sophie was installed. Soon after, we discovered the first exoplanets, and it is a great memory, of course. And I think they were my first one.
Which are the lowest mass and longest orbit exoplanets that you have detected from here?
So here I will say the lowest mass, I'm not so sure, but I would say a few Earth masses, maybe 4 or 5, I'm not exactly sure of the value, but a few Earth masses by comparison to Jupiter, which is 300 times more massive than the Earth. And the longest period, it was not for a low mass planet, it was for a giant planet, but I think the longest, maybe it's 15 years, something like that. We have maybe even more, but a few years. We have several planets that we detect with few years, more than 10 years orbital period. So to do that, we need high accuracy, allowing by the spectrograph Sophie, but we need also long observation because with that method, to detect a planet with 10 years observation, usually we need 10 years observation, and even longer it's better to confirm, to have a good characterization of the orbit. So we can do that because such kind of program, we do that for 30 years, I will say now. So for some stars, we have a time baseline of more than 30 years. So we can detect orbital period of planet as long as Jupiter. Jupiter is 12 years orbital period, or even Saturn in our solar system. So orbital period is nearly 30 years.
Which other celestial observations are done from here?
So we observe stars. So we observe stars to try to detect planets, but we also observe stars to characterize, to study the stars themselves. So there are still a lot of work to do with that. And there is another instrument which is located here, not Sophie, but another spectrograph. And its particularity is to try to observe very far object, galaxy or gamma ray burst. For example, gamma ray burst is a kind of flash that we can detect with a satellite, which is very, very short duration. They can be detected by some satellites who do some survey of such kind of events. And after, with the instrument here, with that telescope, we can try to make fine characterization, once again with spectroscopy, of the object which emitted that gamma ray burst.
What makes this observatory so unique?
Why it's so unique? I will say one of the main reasons is because it detected the first extrasolar planets. So really, that discovery was a revolution. Actually, we were looking for exoplanets for centuries. Maybe some people say, well, it's so long, so difficult, maybe we will never succeed to detect one extrasolar planet. And finally, it was done 30 years ago by Michel and Queloz with that telescope. So it's very an important role in the history of science and even, I will say, in the history of human knowledge. And since then, in only 30 years now, we have thousands of exoplanets. We have several methods to discover, characterize exoplanets. We can detect even the atmosphere of the exoplanets. We have some measurement, detection, studies of the atmosphere of the exoplanets. So really, it was a revolution. And that revolution, the starting point of that revolution, was at that telescope 30 years ago.